Welcome to Blueprint to Reality. Today, we're diving into the fascinating world of bridge engineering, specifically comparing two iconic types of bridges, suspension bridges and cable-stayed bridges. Let's explore what sets them apart. Suspension bridges. Suspension bridges are perhaps the most visually striking of all bridge types. They use cables suspended between towers and hold up the bridge deck with vertical suspenders. This design allows for incredibly long spans, making suspension bridges ideal for crossing wide bodies of water or deep valleys. The key feature of a suspension bridge is its main cables, which are anchored at both ends of the bridge and draped over tall towers. These cables carry the load of the bridge and transfer it to the ground. The main cables support the bridge deck through vertical suspenders, creating a distinctive curve known as the sag. Suspension bridges are celebrated for their ability to cover long distances and their aesthetic appeal. They are particularly effective in environments where the spans need to be very long and where it's challenging to place supports in the water or on the ground. Cable-stayed bridges. Cable-stayed bridges offer a different approach. In these bridges, the deck is supported directly by cables that run from the bridge towers. Unlike suspension bridges, which use a continuous cable, cable-stayed bridges use a series of individual cables attached to the towers in a fan or parallel pattern. The key feature here is that the cables in a cable-stayed bridge are anchored directly to the bridge deck and connect to the towers. This design means that the towers bear a significant portion of the load directly, distributing forces efficiently. The cables are attached to the deck in a pattern that can vary from a fan-like arrangement to a more parallel design. Cable-stayed bridges are known for their efficiency and ease of construction. They can be built with shorter spans compared to suspension bridges and are often preferred for medium to long spans. The design provides a modern and sleek look, making them popular for urban environments and river crossings. Comparing the two. So, what are the main differences between these two bridge types? 1. Span length. Suspension bridges excel in very long spans, often exceeding those of cable-stayed bridges. However, cable-stayed bridges are more efficient for medium to long spans. 2. Construction complexity. Suspension bridges require complex construction techniques and larger amounts of material, especially for the main cables. Cable-stayed bridges, on the other hand, are often simpler and quicker to construct due to their less complex cable system. 3. Aesthetics. Suspension bridges are often chosen for their dramatic appearance and iconic design, while cable-stayed bridges offer a more modern, geometric look. 4. Cost. Due to their construction complexity, suspension bridges can be more expensive to build. Cable-stayed bridges are generally less costly, making them a practical choice for many engineering projects. Both bridge types have their unique advantages and applications, and the choice between them often depends on factors like span length, environmental conditions, and budget. Thanks for joining us on this comparison of suspension and cable-stayed bridges. If you found this video insightful, don't forget to like, comment, and subscribe for more engineering insights. Until next time, keep building dreams with Blueprint to Reality. Welcome back to Blueprint to Reality. Today, we're going to explore a concept that's fundamental to every successful building project: symmetry in structural design. Symmetry isn't just about aesthetics, it's a key factor in making structures more stable, efficient, and cost-effective. Let's dive into why symmetry matters so much in engineering. What is symmetry in structural design? First, let's define what we mean by symmetry in structural design. Symmetry occurs when a structure is balanced and uniform in shape, layout, or load distribution around a central axis or point. This balance can be horizontal, vertical, or even rotational. In structural engineering, symmetry helps distribute loads evenly across the building. A symmetrical structure will have equal forces acting on its foundation, walls, and columns, which means the entire structure can resist stresses more effectively. Whether you're designing a bridge, high-rise, or a residential building, symmetry ensures that the forces, like gravity, wind, or seismic loads, are well-balanced and predictable. Benefits of symmetry in stability. Now, let's talk about stability. Symmetrical structures are more inherently stable than asymmetrical ones because the loads are evenly distributed. This is especially important in areas prone to natural forces like earthquakes or high winds. Take earthquakes, for example. When a symmetrical structure experiences seismic forces, the shaking is evenly spread throughout the building. The structure behaves more predictably, reducing the likelihood of stress concentrations that could lead to damage or collapse. Similarly, in tall buildings, symmetry minimizes the effects of lateral forces from wind or even uneven ground settlement. By maintaining symmetry in both the design and load path, engineers ensure that the building will have better resistance to tilting or buckling under stress. Efficiency and material savings. Symmetry also plays a crucial role in efficiency and material usage. When a structure is symmetrical, loads are more predictable, which allows engineers to optimize the amount of material needed. For example, in symmetrical buildings, columns, beams, and foundations can be designed more uniformly. This not only simplifies the construction process, but also reduces material waste and lowers costs. In contrast, asymmetrical designs may require additional reinforcement in certain areas to handle unpredictable loads, leading to increased material use and higher expenses. Symmetry helps balance structural forces naturally, meaning you don't have to over-design certain parts of the building. This translates to more sustainable construction and a more efficient use of resources. Symmetry in aesthetics and functionality. While symmetry is essential for structural integrity, it also adds to the aesthetic appeal and functionality of a building. Symmetrical buildings often look more balanced and visually pleasing. Beyond aesthetics, symmetry simplifies interior layouts, making it easier to plan spaces, utilities, and circulation paths like hallways and staircases. A symmetrical structure can also make future modifications or extensions more manageable. Since the building is balanced, expanding it or making adjustments won't throw off the load distribution, reducing the need for costly reinforcements or redesigns. To sum it up, symmetry in structural design is about more than just looks. It improves stability, efficiency, and even the aesthetics of your project, while saving time and materials during construction. Thanks for tuning in. Don't forget to like, share, and subscribe for more civil engineering tips and tricks, right here on Blueprint to Reality. See you in the next one. Welcome to Blueprint to Reality. Today, we're diving into one of the most fundamental debates in structural engineering: steel frames versus concrete frames. Which is better for your project? Let's break it down. First, what exactly are we comparing? A steel frame consists of vertical columns and horizontal beams made from structural steel. These frames are like the skeleton of a building, holding up the weight of everything else. A concrete frame is made from reinforced concrete combined with steel bars. Like steel frames, these structures also act as the skeleton but with a much heavier composition. Let's start with steel. Why is steel so popular? Steel frames are incredibly strong and lightweight. They have a high strength-to-weight ratio, which means less material can support more weight. Steel also allows for flexibility in design. Architects love steel because it can span large distances, which makes it ideal for projects like skyscrapers or large industrial warehouses. However, steel has some drawbacks. It's susceptible to corrosion, especially in harsh weather conditions. This means maintenance costs can add up over time. And steel loses strength in high temperatures, so in case of fire, special fireproofing treatments are needed. Now, let's talk about concrete frames. Why choose concrete? Concrete is extremely durable and handles compression well, making it a solid choice for low to mid-rise buildings. Concrete has excellent fire resistance, and it's great for projects where fire safety is a priority. However, concrete frames are much heavier than steel. That means the foundation has to support more weight, which can increase construction time and cost. Another issue with concrete is its low tensile strength, which is why it needs reinforcement with steel rebar to prevent cracking. Finally, let's talk about cost and construction speed. Steel is more expensive up front, but it can reduce labor costs due to faster assembly. Concrete, while generally cheaper in raw material, takes longer to build due to curing times. However, labor costs are often lower than steel. So if you're looking for a quick build, steel is often the better choice. But if you're focusing on long-term durability and fire resistance, concrete might be your go-to. So, which is better? It depends on your project's needs. Steel offers speed and flexibility, while concrete gives you durability and fire safety. Thanks for watching Blueprint TO Reality. Don't forget to like, subscribe, and hit the notification bell for more engineering insights.